This is for Year 12 Specialist. It comes out of 3A. It's sketching a cosec. Remember that cosec of x is equal to 1 on sine of x. I know that the sine of x will look like this. So 1 on the sine of x, where sine is equal to 0, you're going to have an asymptote. And where it's equal to 1, it will stay equal to 1. And where it's equal to negative 1, it will stay. But when this is a half, that's going to be up there at 2. So we end up with a pattern that looks like this. Okay, so that's what the graph's going to look like. So I'm interested in what will the period be. This is a 1 on sine. Because there's a 2 there, it's going to be 2 pi on 2, which is pi. My domain is 1 full pi, therefore I'm going to get 1 complete cycle. So I'd like to find out what the y-intercept is, because the endpoint when x equals pi will be the same value. So y of 0 equals cosec of pi on 2, which is equal to 1 on the sine of pi on 2, and the sine of pi on 2 is 1, so it's 1 on 1, which is 1. So if I was to draw my axis at pi 1, that's going to be the y-intercept, and that's where I'm going to finish. Okay, to find the asymptotes, to find these, it's going to be when the sine of 2x plus pi on 2 equals 0. Now, the sine of theta equals 0 will be given at theta equals 0 and pi and 2 pi and minus pi. So 2x plus pi on 2 equals 0, pi, 2 pi. So 2x equals minus pi on 2, pi minus pi on 2, which is pi on 2, 2 pi minus pi on 2, which is 3 pi on 2. Then we're going to divide by 2x equals negative pi on 4, pi on 4, 3 pi on 4. That's outside of my domain, but these two aren't. So let's break this into pi on 2, pi on 4, 3 pi on 4. So at pi on 4, I'm going to have x equals pi on 4, which is going to be one asymptote. And this one will be x equals 3 pi on 4, which will be another asymptote. This graph is going to look like this, and that there will be at negative 1, and it will look like that, and that will be at pi and 1, and that's at 1, and there is my graph.